So what I was trying to say is, we have already seen what is this vector algebra. So the topic, fourth chapter is called as a motion in a plane. So what do you mean by a plane? That's what we need to understand. So what was the previous topic? The previous chapter was also about motion only. But what is the difference between that one and this one? So there we discussed about the motion of an object in
a straight line.
In a straight line. Then what do you mean by plane? So what do you mean by a plane, guys? So plane means two-dimensional. That is, if you are able to describe something in a two-dimensional space, then we call that as a plane. Okay. So this is what is called as a plane. So in the previous chapter, what we did is we discussed only about an object moving along x direction separately, or you would have a case where the object is moving only along y direction. For example, the concept of motion under gravity. Whereas in this chapter, what will happen is the particle will not have a confined motion only along x-axis or y-axis. It can move in the xy plane. It can move in some random shape. Okay. If there is some object which is moving along this particular curve, then we call the motion of this object to be in motion of the object to be in a plane. Okay. So that's why we call this chapter as motion in a plane. So in motion, I told you there are two important topics. One is called as projectile motion and the second is called as the vector algebra. So if you recollect, vector algebra is what we started with, right? So there are certain...
Sir, voice is breaking, sir.
Guys, you have to respond or else...
Sir, voice is breaking, sir.
Mithun, I just finished a class. I didn't have any issue. I'm just trying to connect with others. Confirmation. Is it a problem on my side or something on his side? I just need to know. No.
Sir, even for me, your voice is breaking.
Even for me, sir.
Even for me, sir.
Breaking? Okay. You have to tell no. So listen. So addition of vectors, subtraction of vectors, product of vectors. Then we had a concept called as resolution of vectors. Right. So these are all the concepts we had. Do people remember them? So we had them. So that part we have already discussed. Now what I'm going to do is I'm going to discuss only about the projectile motion. Okay. Listen. So the topic is so write down the heading as projectile motion. Okay. So have this word projectile motion from your school. Yes or no? Yes or no? So if I take this as x-axis and this as y-axis, I project an object at an angle theta with respect to the horizontal and with speed u. Okay. So what do you think will happen to this particle? What do you think will happen to this particle?
So move along both x and y axis.
So move along both is okay. What is the trajectory means? What will be the path followed by it? See, for example, I'm asking you a question like this. There is a level road on which I've kept a toy car. I'm just giving it a velocity like this. If I ask you, in what direction will this toy car move? What will you say?
Right direction.
I cap, positive x direction.
Okay, it is going to move in the positive x direction. If I ask you, what is the path followed by it? What will you say? What is the path followed by this particular car? What will you say?
West.
Sorry? Somebody told it. Sorry, can you repeat it?
West.
Rest.
West.
No, I'm not asking about direct east, west, north and all. I'm asking about what is the path followed by it. Path means what kind of a shape does it follow? If I try to join all the points along which it is moving.
Rectilinear motion,
So rectilinear means what is that actually?
straight lines.
Straight line
It's
motion.
a straight line motion, right? So here the object is going to move in a straight line. So I've given the velocity like this, and the particle is still moving in the same direction along the straight line. So what have I done here is, I've given the particle a velocity u. So can I say that the particle will move in this direction? So here you told it's a straight line, right? So if I try to project a particle like this, so the particle will try to continue to move in the straight line motion like how I've drawn it in the diagram. Is that right or wrong? Is that right or wrong? I didn't get you. I didn't get you. Somebody answered it. Again, please, no. Unless we have some discussion, you can learn no physics from me. Open your mouth and speak. Even if it is wrong, no problem. Try to answer.
Yes, sir.
So is this right?
Yes, sir.
The answer is
No, sir.
No, sir.
why?
It would reach a maximum height and then fall back down.
What is the reason for it?
Because gravity pulls it down.
Gravity.
It is because it is traveling under the influence of gravity. Right? You people have played Angry Birds game? Yes or no?
Yes, sir.
Yes, sir.
So how does the bird move? So if this is the target, so you have a bird here, you try to pull it, no? Then what will you do to hit the target? It will show you some path like this, no? Depending on how you are trying to pull. Will you guys observe that? So if suppose you pull it down like this, then it will show you a trajectory like this. So there is a target. Based on this only you will project it, no? Did you guys do this or not?
Yes, sir.
Right. So what exactly is happening there? So here is the bird. You gave a velocity to it in this direction. So what is happening to that bird is, now there is a concept called as resolution of vectors, if you guys recollect. So that was the last topic I taught in vectors. So if there is a vector like this, a vector, if this is theta, then I would have told something. This a vector can be resolved into two components. What are the two components? What are the two components, guys?
Two perpendicular components.
You can resolve it
Cos
into
theta.
two perpendicular components. One is called as a cos theta, and the second is called as a sin theta, which is cos and which is sin. So if there is a vector A, wherever the angle is present, then that will be cos theta. the opposite one to that will be a sin theta. Are you able to recollect this concept? Are you guys able to recollect this?
Yes, sir.
Okay. So what happened in the previous chapter is, when you try to move the object along this path, along the horizontal path, when you try to move the particle along the horizontal path, you gave what velocity? You gave a horizontal velocity. So the particle tried to continue to move in the horizontal direction. Whereas when you try to move the particle in the vertical direction, what was happening to it? When you try to project the particle in the vertical motion, it was traveling under the influence of whom?
Gravity.
Gravity.
It was traveling under the influence of gravity. So in the previous chapter, we either dealt only with horizontal motion, like motion of a car, motion of a train, a person walking on a road, all these kind of problems, or we dealt with motion of an object under the influence of gravity. Whereas here, what is going to happen is, there will be a motion of an object which is taking place along horizontal and along vertical simultaneously, right? So when a particle is moving along horizontal direction, we need to understand what are all the forces acting on that object. When it is moving under the vertical direction, what are all the forces acting on the object? Okay. Now see. So listen to it carefully. Okay. So x-axis and y-axis. So if a particle is projected at this angle theta, so this is the bird that is trying to hit the target here. The target is here. Okay. Based on that, you will be adjusting, no? So what exactly happens is, once you release the trigger here, the particle tries to travel like this, right? And what will happen to it? It will reach a point along the vertical, which is called as what? So along the vertical direction, what is the maximum displacement called as? We dealt it in previous chapter also.
Maximum height.
So it reaches a maximum height and it will come down and hit somewhere else. So in this case, what is happening? Is it hitting the target or not?
No, sir.
No, right? Because we took some wrong angle or we gave it a wrong velocity. We don't know. Okay. So this topic is all about how you are going to project the object to hit a particular target. Okay. So that is how you can listen. So this kind of a motion of an object is what is called as projectile motion. So motion of an object under a plane, or under the motion of an object under the influence of gravity as well as along the horizontal direction, is what is called as a projectile motion. Now, this is what we have analyzed, and we have told that this is the type of motion that is going to happen. Right? I hope it is clear till this step. Now we are going to analyze the physics behind it. Now, what is making the object move along the horizontal direction and what is making the object move along the vertical direction? Okay. So one thing is clear for us if you recollect, okay, though we have not discussed this, from your 9th standard, I am going to ask you one question. What do you mean by Newton's first law?
Like stating it, sir.
Yeah.
An object is said to be in rest until an external force is acted.
Yes. An object is going to be at rest or in uniform motion unless there is an external force acting on the object. So, for any object to move, you need to apply some force. Okay. So, when you say you're applying force, you're trying to give a velocity to the object at that point. Right? So, what exactly happens here is you have given the velocity to the object neither along.
I am not able to hear you, sir.
Listen. You have given the velocity to this object neither along the x direction nor along the y direction completely. Am I right? So you have given it at some angle theta other than. So if I give, see, for example, I'll put a question like this. If I give the velocity completely along horizontal direction, what would have been the angle of, what would be the angle the velocity is making with x-axis? Had I given,
0.
had,
0.
it would have been 0. Had I given it completely along vertical direction,
90 degrees.
90.
it would have been 90. So for a projectile motion to happen, your angle of projection should be somewhere between
0 to
0 and
90.
90.
somewhere between 0 to 90 degrees, other than 0 and 90. Am I right? When this is going to happen, what exactly will happen is applying this concept. Now here the vector A is nothing but u. This u can be resolved into two components. What are the two components? So this u is in which quadrant?
First.
So first quadrant means you can resolve it as positive x-axis and positive y-axis. Now you tell me which one is cos theta and which one is sin theta.
X-axis cos theta, sir.
So what cos theta?
U cos theta.
Cos theta.
It is cos theta, and y-axis is
U sin theta.
u sin theta. I hope it is clear till this point. So what exactly is happening is, though you have given the velocity to the object in some xy direction, the u is getting resolved into two components such that this u cos theta is taking care of the object to move along the horizontal direction, and u sin theta takes care for the object to move along the y direction, and both are happening simultaneously. That is why the particle is neither completely able to move along x direction or y direction, rather it is moving in an xy plane. Are you guys able to visualize this?
So could you just repeat the last part?
I'm saying the u cos theta is trying to put the object in which direction? In the positive x direction. In this case, u sin theta is trying to put the object in
Vertical
positive y direction, in the vertical direction. Okay. So the particle is neither completely moving along x direction nor completely moving along y direction. It is moving in an xy plane. It is because of the combination of these two velocities put together.
Okay, sir. Understood.
Okay. Yeah. So this is what happens, and the particle hits some point on the ground on the other side. Okay. So this point, if I take it as origin, then the horizontal distance traveled by the object is called as the horizontal range. I'm just giving the terms, okay? Definitions I'll give you. So horizontal range means what? The maximum horizontal distance traveled by the object. Then from the ground, what is this distance called as?
Vertical range.
Sorry?
Maximum height.
It is called as the maximum height. Okay. Similarly, what is the time taken for the particle to go from O to A? It is very much similar to motion under gravity. Object to reach from bottom to the highest point. Sorry, time taken for the object to reach from the bottom to the highest point. Time of
flight.
ascent. So time of ascent is time taken for the particle to go from O to A. Then from what is the time taken for the particle to go from A to B?
Time of descent.
Time of descent.
Time of descent. Now what is time of flight? Time of ascent plus the time of descent. So in this particular projectile motion, there are only three parameters we are going to derive. What are they? One is maximum, the horizontal range, and the next is the maximum height, and the third is time of flight. These are all the three derivations that we are going to see in this chapter. But tell me one thing, are you people clear with what is the physics behind a projectile motion? Or is there any doubt which is there in your mind?
Clear, sir.
Clear, right? That's good. Okay. So now tell me one thing. When the object is moving along the x direction, what force is acting on the object? Is there any force that is trying to stop the object?
Yes, sir.
What is it?
Gravity.
But gravity, so listen to my question clearly. I'm asking about horizontal direction. Is there any force acting in the horizontal direction?
Friction, sir. Friction.
Air resistance.
RSA.
Air resistance is supposed to act. If I ignore air resistance alone in this case, will there be any force?
RSA.
No, sir.
There is no force. Okay.
RSA.
Whereas in the vertical direction, what is the force acting on the object?
Gravity.
Gravity.
Gravity. So, what is the direction of acceleration due to gravity? It is always downwards. So, the acceleration due to gravity is always downwards. Whether the object is moving in the upward direction or whether the object is moving in the downward direction, the acceleration due to gravity is g in the downward direction. I hope there is no doubt on this, right? So, make a note of it. There is no horizontal force acting on the object. There is no horizontal force acting on the object. Hence, the object does not accelerate along which direction?
Along positive.
Along the horizontal direction. Yeah, here in this case, it is positive x-axis. Okay. In the vertical direction, what is happening? The object is moving under the influence of
Gravity.
yes. So object is moving under the influence of gravity. From O to A, is it accelerating or decelerating? When we are going from O to A, is the object accelerating or decelerating?
Accelerating.
I didn't get you.
Sir, RSA.
When the object is going from O to A, is it accelerating or decelerating?
Sir,
Accelerating.
Accelerating, sir.
It is decelerating. Why? Because it is traveling in the direction against the gravity. Gravity is in which direction? Downward direction. But the object is trying to move in the upward direction. Correct? So what is happening from A to B?
It is accelerating.
Here it is accelerating. Because the gravity is supporting the motion of the object. Are you guys able to understand till this point? So, what I'm going to conclude here is the acceleration along x direction is going to be 0 and the acceleration along y direction is going to be here. What will be the acceleration along y direction?
Minus c and then plus c.
It is here I will raise it minus g and plus g. So, depending nature of the motion, whether it is going the upward direction or downward direction, I'm going to use minus g or plus g. Is there any doubt, guys, till this point? If there is any doubt, get it clarified. Is there any doubt?
No, sir.
Okay. So what are all the three parameters I told we need to calculate? We need to calculate the maximum height, then horizontal range, and the third is time of flight. So here we are not concerned about time of ascent and time of descent. Okay. So maximum height is given by the symbol h max. Horizontal range is given by the symbol capital R, and the time of flight is given by the symbol TF. Right? So first derivation that you are going to see is for maximum height. So for maximum height, what is happening is let's recollect it. This u sine theta and this is u cos theta and this is this h. Now at this point, what will happen to the velocity?
So at which point, sir?
At the highest point.
Velocity will become 0.
0, sir.
Velocity becomes 0. That's what we saw when we discussed about motion under the influence of gravity, right? When it goes to the highest point, its velocity should be 0. But in this context, you need to be careful about stating which velocity is 0. Is it the vertical velocity that is 0 or the horizontal velocity that is 0? Okay. So for that, make a very, very important note. Make a note. Since the acceleration along x direction is 0, the object or the projectile has a constant velocity along x direction. So from this, what is important to be noted?
The velocity along its direction is always constant.
So the projectile has a constant velocity along the x direction. So x direction at this point will still have the same velocity u cos theta. But what will happen to the vertical velocity?
It is 0.
It is the vertical velocity that is decreasing and it becomes 0 at that instant. So what is the difference between motion under the influence of gravity and this one? So for the object which is moving under the influence of gravity, there is only vertical velocity. So at the highest point, we don't mention the vertical velocity is 0, it is understood. Whereas in the case of a projectile motion, the vertical velocity is 0 and the horizontal velocity is u cos theta. Okay. And because of this u cos theta only, the object further continues to move in this direction. Okay, that is why it is able to do this. Or else what would have happened? If this u cos theta would have also been 0, then what? Observe the motion. No? It has gone to highest point. No? The velocity here was 0. The object would have fallen like this.
There are some background voices coming, sir.
Yeah. Somebody is shouting from outside. Now is it better? So if it has gone to the highest point, if you say the velocity completely is 0 at this point, means horizontal is also 0, vertical is also 0. The particle should have fallen like this. Are you able to understand this point? But what exactly is happening? Is the first scenario happening or the second scenario happening?
First.
The first is happening. So what should happen? U cos theta should now be equal to 0. So observe at maximum height what happens is, since Vy is equal to 0, applying, so observe the way I'm going to apply, okay? Applying V is equal to U, applying V square minus U square is equal to 2as. This V square minus U square is equal to 2as should be applied in which direction? Maximum height is confined to which direction? Y direction or X direction?
Y.
So I should put the symbol Y. Is it clear? Okay. Now what should I substitute for Vy?
0.
0 minus what is the value of Uy?
Sin theta.
So U sin theta, the whole square, is equal to 2 into what is the acceleration along Y direction?
Minus g.
Minus g till it reaches the maximum height. And what is the displacement along Y direction? So all this story is happening at a distance of h max from the ground. So h max. So minus and minus will get cancelled. U square sin square theta is equal to 2 into g into h max. So what is the value of h max? It will be u square sin square theta divided by 2g, and this is an important formula for you to remember. Is there any doubt till here? Is it clear till this step, guys?
Yes, sir.
Okay. Now I'll ask you an important question. When we discussed about the same concept, the concept of maximum height for an object moving under the influence of gravity, what was the formula we got?
U square by 2g.
U square by 2g. So here, for example, if theta is equal to 90 degrees, okay. So I asked you a question. You people told me, if I take this as theta, if theta is equal to 0 degrees, the object is projected along horizontal direction. If theta is equal to 90 degrees, it is projected along vertical direction. If I take this theta is equal to 90 and substitute it here, then what will be the value of h max? U square sine square 90 divided by 2g. Right? What is sine 90?
1.
So what is the formula you are getting? U square divided by 2g. Is it not the same formula that we studied there?
Yes, sir.
So you're able to understand. So this concept can be related there and studied. Because here you have both the combination of horizontal as well as vertical. Okay, this is a special case. Okay, you can make it as a note. Guys, I hope it is clear. Everyone.
Yes, sir.
Yes, sir.
Okay. Now listen. So if you're done copying this, I'll go to the next one. Now listen. The next concept is calculating the time of flight. So time of flight means obviously the time taken for the particle to reach from the initial to the final point. Right. So observe what I'm going to do is, so this is 0, 0. If I take this distance to be r, okay, what will this point be? This point will be r, 0. Is there any doubt in this? I'm taking a basic coordinate system and trying to derive. Is there any doubt in this, guys? So I've taken it as 0, 0 and r, 0 because x-axis is going to be r and y-axis is going to be 0. Now I'm going to put an important question. So what is the displacement of the object between the point O and B? I'm repeating it again. What is the displacement of the particle between the points O and B?
R.
It is R.
Yes, yes, sir.
A is obviously here. That's what I took in all the diagrams. So what is the displacement between O and B? You people told R. But I'm saying you should have asked me a question. What is it? What is the displacement between the point O and B along x direction? How much is it? Along x direction is what is R. But if I put a question like, what is the displacement of the particle along the y direction? What will you say?
0.
It is 0. Because in the y direction, it has not moved at all. Right? So, if you apply S is equal to ut plus half at square along which direction? Along y direction. Okay. So what is the displacement of the particle along y direction in this case? It is 0 is equal to, what is the velocity of the particle along y direction? Initial velocity of the
Sin
particle.
theta
U sin theta into t plus half into acceleration along y direction is
minus g.
minus g into t square. Correct? So u sin theta will be equal to g by 2 into t square. U by sin theta. Okay, I'll do one thing. See how I'm going to write this. U sin theta minus g by 2 into t, the whole multiplied with t is equal to 0. Are you guys able to understand what I did? Mathematically, I took out t outside and then tried to solve. So t is equal to 0 and t is equal to 2u sin theta by g. So there are 2 times that we are able to get it from a quadratic equation. Right? So what does this t is equal to 0 represent? What does this t is equal to 0 represent? T is equal to 0 represents the initial time at which the particle was projected. Okay. T is equal to 2u sin theta by t represents the time at which it is again hitting the ground. And this is what is called as the time of flight. So at t is equal to 0 and t is equal to 2u sin theta by g, what is happening? If you observe the displacement of the particle along y direction, it is 0. Are you guys able to understand? So I've underlined C. If you observe the displacement of the particle in both the cases, it is going to be 0. And this is going to be the formula for time of flight. Okay. Again, the same question. If the object is projected along vertical direction, what will be the value of theta? If theta is equal to 90 degrees, then what is t time of flight equal to? It is 2u sin 90 divided by g. So that will be 2u by g. So time of flight is equal to u by g. Did you guys understand what I did here?
Yes,
So
sir.
go and verify if this is the same formula that we have. T is equal to 2u sin theta, sorry, 2u divided by g. Right?
Yes, sir.
Okay. So if you're clear with this, I'll proceed to the next concept. You want to copy?
I have a doubt.
Yeah, tell me.
T common, no, sir. That's all you did.
Yeah, I've taken this step, no?
Sir, you just took T common.
I've taken t common. That's it.
Okay, sir.
Yeah. It's a quadratic equation in t. I've taken t common and I got the answer.
Okay, sir.
Done with this?
Yes, sir.
And the last concept is horizontal range. So horizontal range is represented by the symbol capital R. Write down the definition for it. The maximum horizontal displacement of the particle. The maximum horizontal displacement of the particle during the complete journey. The maximum horizontal displacement of the particle during the complete journey is called horizontal range. Okay. Now listen. For horizontal range, applying S is equal to ut plus half at square along x direction. Okay. So what is the displacement of the particle along x direction from O to B?
R.
So R is equal to, what is the value of Ux?
U cos theta.
U cos theta into what is the time it takes for the particle to go from initial point to final point? We have derived it previously.
2u by g.
That is time of flight. No, 2u by g is for vertical motion. This is the formula you need to remember. It is a time of flight. Plus half into acceleration of the particle along x direction. So acceleration of the particle along x direction.
0.
0. So R will be equal to u cos theta into time of flight is 2u sin theta the whole divided by g. Right. So u multiplied with u is u square. U square into 2 sin theta into cos theta the whole divided by g. Right. U square into, what is the formula for 2 sin theta cos theta? It is called sine 2 theta divided by g. So the formula for range is R is equal to u square sine 2 theta divided by g.
Sir, if u and u are common, then we should take only u no sir as common. Then
Right.
y square, sir.
And for Mithuna, you are able to understand. Huh? Did you understand what I did here?
Yes, sir.
But what is there in the? What is there in the? Then why will I take that u common? You need to take it common only when you have addition or subtraction. Okay, don't do that mistake. So it is u square sine 2 theta divided by g. So with this, 95% of the chapter is over. Because I've already taught vectors, but it is clearly visible, you guys didn't revise it again, right? So 95% of the chapter is over actually, because there is only one topic that is left out, which is called as there is only one topic that is left out, which is called as equation of projectile. With this chapter is over. So that I'll be completing tomorrow. Okay. I just wanted to show you a simulation and ask you questions. Wait. No, listen. See, here you have an object. Okay. So this is a target. You guys are able to see I'm moving the target. Yes or no? At least answer for this. Yeah, you're able to see. See. Now the question is, I'm setting the initial speed to be 18 meters per second. Listen to my question carefully. I'm setting my initial speed to be 18 meters or let's say 15 meters per second. I'm setting the target as 25 meters. Now I am asking you, what should be the angle of projection? Right, you're able to see when I try to rotate this cannon, The angle is changing. So I don't know what should be the angle of projection for me, so that when I project this particle, it will go and hit that 25 meter. So let's say this is the question. And how will you approach? Did you guys understand what I asked? So I'm simply asking you what should be the angle of projection, so that the object which is projected with a speed of 15 meter per second is able to hit a target which is at a distance of 25 meters from it. Now, how to proceed? Hi guys, there you're able to hear me.
Sir, should we substitute the formula, substitute the values in the formula, sir?
What formula?
Horizontal range, sir.
So horizontal range should be how much?
25 meter.
That's right. Horizontal range should be how much? So here, what is the target I have set? Target is at a distance of
25 meter.
25.
So R should be equal to 25 meter. Okay. Now, initial velocity is 15 meter per second. Theta is equal to how much? So that all these things are happening. So R is equal to U square sine 2 theta divided by G. Correct? What is the value of R?
25.
Is equal to U square is 225 into sine 2 theta divided by what is the value of G, guys? You can take it as 10 for the time being. Okay. So if I cancel this and this, I get 22.5. So 25 and 22.5 are divisible 0.9 times, correct? So that is nothing but 9 by 10. So sine 2 theta will be equal to 10 by 9.
Yes,
Is there
sir.
any doubt till this step?
No, sir. No, sir.
Did you guys understand what I did?
Yes, sir.
Yes, sir.
So sine 2 theta is equal to 10 by 9. So what is the angle of theta that you can substitute here such that sine will give you 10 by 9? What is the answer?
Ten by 18.
Are you guys there? Please speak
Yes,
something.
sir.
Guys, are you able to understand or not? I have an important point to tell here. Nobody is responding.
Understood, sir.
Respond to me in the chat box if you're able to hear me or not.
Yes, sir.
Understood is fine, but I'm asking an important question because what happened? I'm waiting for your response. Wait. So what is the answer then?
So is it 10 by 18?
Anand, unmute yourself and speak.
Sir, can you hear me? Sir?
Wait. Now speak.
Sir, is it?
Yeah, now it is better. I think there is an issue on my side. And now I'm able to hear. Atul, speak. Harshita, speak.
Sir, I'm not sure about the answer.
Yeah, Harshita, I'm able to hear. Okay. See, one important point of what I wanted to share here is, listen. So in this problem, so my iPod also got disconnected. See, think about this. The answer is sine 2 theta is equal to 10 divided by 9. No? Think about this. I'll continue tomorrow's class from here. Okay. Not sure if you guys are able to hear me. I'm not able to hear you.
Okay, sir.
Okay, sir.
Yeah. Okay, then we can end this session.
Thank you, sir.
Yeah.
Thank you, sir.